Hello everyone. I hope all of you are doing good today. I'm Sanjana from HackVerse NITK, and today we present to you Deep Learning Foundation for Self-Driving Cars. But first, what is HackVerse? HackVerse 3.0 is a 24-hour nationwide hackathon to endeavor and motivate zealous minds to brainstorm ideas and provide solutions to real-world challenges. We provide a platform for innovation where developers can analyze these real-world problems and use their creativity to come up with a solution. HackVerse 3.0 will be conducted on the 26th and 27th of this month, that is February 2022, and registrations are now open, so please do register for it. The link will be provided in the description below. And also do follow us on social media and be the first to get to know about all the announcements and giveaways. With that, let's move on to today's topic. Self-driving cars are certainly the future of transportation, and for those who are curious about how such an amazing technology would work, you don't have to look any further because today, to talk about deep learning based models on object detection and segmentation that are the underlying concepts for self-driving cars, we have with us Mr. Mohit Uniyal, who is a data scientist and a co-creator at Coding Minutes. Not only that, he is also a mentor at TensorFlow at Google Coding. Over to you, Mr. Mohit.
Thank you very much, Sanjana. Could you please confirm if I'm audible and visible?
Yes, sir, you're audible and visible.
All right, all right. Thank you. Hey, everyone. Good evening. Maybe we can wait for just 1 or 2 more minutes, let everyone join, and then we will begin the session.
Sure, sir.
Can anyone from the audience comment if you're familiar with deep learning models and especially the CNN, convolutional neural networks? Just wanted to understand the brief background of the audience. Good evening. No, Sonali says no. Manchi says no. Some basics of CNNs. All right, all right, all right. No issues. So I'll be talking about the self-driven cars and especially the underlying topics and why do we use deep learning models for the self-driving cars. But before moving into or before directly jumping into how self-driving car works, how many of you do not know about what is self-driving car? Maybe we can understand the problem statement first and then we'll jump onto the solutions. Have you ever seen self-driving car in around you? Maybe on roads. Anyone? Have you ever seen a self-driving car? And obviously, we will be understanding the challenges, pros, cons, and why do we call self-driving cars a futuristic topic or futuristic technology? And no, no. As expected, we generally do not see self-driving cars, especially in Delhi or let's say in India, right? Hmm. Okay. You know the concept. Good, 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 good. I think we can now get started with the topic. Let me share my screen so that we can first understand the problem statement and then we'll talk about the briefly high level machine learning design or the deep learning design of the self-driving cars. Meanwhile, if you have any questions, if you're stuck, if you're not able to understand how things are working, you can just simply post or put your questions in the chat. And obviously, at the end of the session, we'll be doing a quick Q&A as well. All right. So we'll be understanding how self-driving car works, but let's first understand the problem statement. And I hope most of you are already familiar with what is self-driving cars, right? Not how it works. But what is self-driving car? I think everyone would be familiar. So let's say there would be a car, pick any car, and you don't have to operate that car. That car can drive on its own. So that's what autonomous vehicle or autonomous technology or self-driving cars actually mean. So let's also understand that how uh, a person, a normal person like a human, drives car, and how the car can drive on its own. So what do you think? I'm drawing a car. Let's say if this is a car, okay. Let's say this is a car, and you are drawing. You're driving a car. So what are the different inputs? Let's first talk about the different inputs. What do you think? Obviously, if you're creating a machine learning or a deep learning model, definitely it would be a black box and you don't understand what is happening. We are talking about very high overview first, okay, then we'll go into the depth. What do you think? What would be the inputs? What would be the inputs to this black box model? Because you need to give some inputs, and then this model will. You cannot see your screen. Okay, I hope the screen is now visible. Good. Thank you. Okay. Let's say you give some inputs to the machine learning or a deep learning model. This is your model, and you'll get. I hope it's visible now. Okay, and you'll get some output. Okay. Let's first talk about the inputs. What do you think? What would be the inputs to that machine learning or a deep learning model that actually drives this car automatically on its own? Any idea? If you do not have any idea what would be the inputs, think about how a human drives a car. If you're driving a car, what would be the different signals or inputs that you would be taking, and based on those inputs you would be doing some processing, right? And put some action or do some actions, maybe turn the steering angle to right, or maybe press brakes, accelerator, and all these things. So Sonali says that okay, one is sensors, okay. Camera camera Okay, all right. So camera basically means you can have video or images. Images are nothing but the sequence of videos only, right? So this is what the input is. Any other input? Any other input? So mechanism to detect nearby vehicle. This is not input, but this is what actually happens inside this box. Inside this model, the mechanism to detect nearby vehicle is actually what happens. This is not input. But how do I detect, or if I do not have the images or if I do not have the videos, then I won't be able to detect. Correct. Radar or lidar. Correct. We'll be talking about this. Those who do not know about this, this is basically the remote sensing technologies that you can use to find the distance between two objects. Okay, we'll be talking about this as well. Slightly advanced topic, but we'll be talking about this. So instructions. Not exactly instructions. This model learns instructions on its own. The primary input should be, I think you have already covered this, it should be the video and images, or basically the camera. So I hope everyone know, if this is a self-driven car, there will be a camera on the top of the hood of this car, and this camera would be capturing whatever happening in front of the car. Okay, what do you think? The front camera would be sufficient, or do we need a camera at the back as well? Okay, so probably we need to have a camera at back as well that can also see that okay, there are two or three different cars, and what is the distance between these cars. So subject says basic traffic rules. Again, traffic rules, we can get the traffic rules from the images or the videos. For example, if there is a red signal or maybe a green signal, we can get this information from the images. So I think primary input would be video or images that we can get from a instrument, or you can say a device called camera. Simple. By the way, there are uh, there are some different inputs as well. There are more inputs. For example, you need to take location as well, right? You need to take your current location as well. Okay, there are some more input. For example, you need to understand what is the signal, or what is the instruction in as for example, voice instruction that is given to this car. Okay, but these are the secondary. These are the secondary inputs. The most important one would be the primary, which is the camera and the video images. This we have already understood now, that there will be a camera on top of the car, and it will basically input all this videos or images. Now, what would be the second step? Okay, input we have understood. Let's talk about the output. What do you think output would be for a self-driven car? It has taken a image, or let's say a video, and since video images are basically multiple sequence of images will form a video. What do you think? What would be the output at any timestamp t? Let's say at any timestamp t, what would be the output of this model? Now think at this time, think about how do you, or what processing you do when you are driving. At the first step, you have thought that, okay, what would be the inputs? Okay, now what processing would you do with these inputs? Output would be the destination point. Obviously you have to reach there, that's the ultimate goal. But at any timestamp t, what would be the out? Good. I think I got one answer, which is a steering angle. Good, steering angle. Okay, good. Also, speed. Okay, and controls. So all these things comes under the control. For example, speed or maybe brake, right? You sometimes you would also have to put the brakes as well. So all these things comes under the controlling of the car. Okay. Then image processing you have to do, but what type of image processing would you do? Okay. Definitely image processing, video processing, this we have to do. But what type of image processing we would have to? Location of the different object. Good. Location of different object. Now different objects can be different cars, other cars, maybe pedestrians as well, or traffic signals, or maybe road signs. For example, there's a sign called stop. Now if they have written, or they have put a sign called stop, you need to stop. Okay, so location of different objects. Distance between object is one point that we have covered. If you talk about a very basic self-driving car, then I think these first points this points would be sufficient, that hey, do you need to take this car needs to take a left turn, a right turn, or do I need to press accelerator to move forward? Okay, or do I need to press a brake so that I can slow down? I think these are the four major controls that any car, for example, if you are trying a radio control or remote control car, generally these four are the major controls that you will see. So if you talk about a very basic self-driven car, then these four would be sufficient. That hey, if there's a left turn, I can take a left turn. So my model can at any point t, my model can output that you need to take a left turn. So let's take the steering angle and tilt it towards the left. Similarly, tilt it towards the right if I move to right. And if there's no other object in front, or there's no other car in front of me, then I can maybe press accelerator or press brake if required. So these are the mandatory, these are the basic operations. But a lot of things they have to do. Okay. Now this is the input, this is the output. Understood. What type of processing we have to do? What type of processing we have to do? I think this would be the most important thing to understand. Okay. What So how this model is able to take inputs and predict something, that hey, there's a car in front of you, you need to press brake, or there's a left turn, you need to take left, or maybe steering angle will be towards the left. Okay, we will understand how to do this processing. So all these things are done using machine learning, or typically these days we do not rely with machine learning because they are the traditional classical old algorithm. Uh, since the advancement of research areas like deep learning, convolutional neural networks, or neural network in general, we typically use deep learning over here. Images, object, traffic signs using unsupervised model. No, not unsupervised, it would be supervised model. We will understand how it is a supervised model in maybe in a while. Okay, so we typically use deep learning, and even in deep learning there are models like convolutional neural nets. in short, we call them as CNNs. Okay, so oftentimes we use these type of models to build a self-driving car. Okay, before now going into how do we do this processing, image processing, video processing, I want to ask one question. Let's say I have to build this self-driving car model, or whatever the processing is required. I have to create a new algorithm, and I want to test on a real car. I want to test on a real car. What do you think? What would be the challenges? Can I create a self-driving car model in my laptop and put it on, just put the camera on top of my car, and then let's go ahead on open roads? Can I do this? What would be the challenges with the real car? If I apply this algorithm or all these modeling with a real car, what would be the challenges? OpenCV typically we use with Python, but if you want to use with C++ as well, no challenges with that. We can use OpenCV with C++ as well. But since a lot of people have started using Python, so that's why more popular. It's more popular than just basic C++. Okay, what would be the challenges if I take my machine learning or deep learning model, which I have trained on my laptop, and directly put it in the production, which is on a real car? I hope everyone understands that lot of challenges, lot of issues, especially in India and Delhi. Uh, we cannot think of a self-driving car running on old Delhi Chandni Chowk area, right? We cannot think of this. It's not possible, right? In near future, today, forget it. So what we do is, what we do if we have to build, because it's not accurate, right? It is not safe. Safety will be a big major issue, challenge, traffic. Correct. Okay. So what we do, if someone needs to work on self-driving car, what they do, instead of using a real world example, we try to build this model with a racing game. Okay, with simulation, with on racing game, or something called simulations or simulators. So there are a lot of simulators that AI community or research community use. One simulator is called TORC. So if I search for this, it actually stands for the Open Racing Car Simulator. Okay, Kaggle dataset can be used, but we can create our own dataset as well. So if anyone needs to build a self-driven car, maybe you can first start with this website. You can download this tool. Okay, it's open source software. You can download this. If I go over here, you'll see that there will be a download option. Okay, you can download, play around with this. You can capture the data. You can get the data, and also you can evaluate how your model is working or how your self-driving car is running on the simulator. Because even if you have collision, even if you have collision in this game, it's okay, right? This is just a game. So here you can actually understand how your model is working, or if your deep learning model is fine, and you can test it in the real world. So typically, everyone in the research community, everyone start with a simulator. Okay, one such simulator is this, and it's very popular. That's why people use this one. Okay, now, obviously, if you would have to build a self-driven car, you would be using this simulator or maybe some other simulator, or maybe a game which is Need for Speed, right? So you can collect the data from there as well and train the deep learning model. But uh, but typically, we never, in the very first go, we never try it on the real world car because of some obvious reason that you understand now. Okay, let's also understand why deep learning is used. Okay, now there will be a lot of complications. So what I'll do is, I'll try to divide this session with in maybe two parts. One where we'll be talking about self-driving cars when in an empty road. Okay, in an empty road, in empty road. So in empty road, it's very easy as compared to traffic. Okay, and I hope you understand why. Because there would be lot of other cars. There would be different things that you would have to handle. In empty road, I think it would be comparatively easier, because you just need to maybe press or find what would be steering angle, left, right, front, back, all these things. These 4 or 5 basic outputs that you need to get. Okay. All right. So the first thing that I want to understand, and if I have to do the processing, right? So we are talking about the processing. Whatever the inputs we have to do the processing. So the first processing that I would have to do, it would be something known as lane detection. Okay. Now, what is lane detection? Let me give you an idea. Let me give you an idea. What is lane detection? Let's say this is your road. Uh, Typically what happens is, let's say road, there's a road and then there is this marker. Okay, now if you have a car which is over here, I cannot draw a car properly over here. Maybe let's say this is your car, this is a box, this is your car. What you need to understand is uh, where you can drive in this entire road. What area is there to drive? Okay, obviously you cannot drive over here. Maybe let's also draw one thing. Let's draw, there are some trees. Okay, let's say there are some trees over here, and similarly over here we have some trees. So the first thing that would you would do is called lane detection. Lane detection actually gives you the border. So let's say this is the border, this is the leftmost border, that you cannot go beyond this border. Okay, you cannot, your car cannot go beyond this border. Similarly, there is this border, rightmost border, that your car cannot go beyond this rightmost border. And obviously you can also find this middle line. Okay, at any point t, your car will have some coordinates. Okay, your car will have coordinates, like maybe currently I am at x and y coordinate. Okay, for example, if your car is at this point, obviously this would have maybe some x and y. What you need to understand is, let's say if this is the leftmost part, this is the rightmost part. Okay, what you need to understand is, at any point of time, your current x and y car coordinate should be less than your let's say this is x left and y left, and it should be less than equal to x right and y right. Do you understand why this needs to be true? I think this is obvious, right? Because you cannot, if your x and y coordinates are less than left, then you are colliding with, maybe you're going off track. Okay, similarly you cannot move right of this border. Okay, so this is called the lane detection, and I'll actually show you how this look like in when you actually do this lane detection. So it looks something like this. Why we use equal? Okay, we can avoid using equal. Yes, true. We can avoid using equal. Okay, true. It depends on a lot of things, that if you can keep a margin of, let's say, 10 pixels over here, 10 or 15 pixels, you can keep that as well. If it is false, then everything in algorithm will not work properly. That's true, right? Because this is the first, why I'm telling you this is the first step, because the first rule of driving is that you need to drive straight, if obviously the road is straight. And sometimes, like as a beginner, what we have suggested, that drive in center, or maybe drive just straight. Don't go zigzag, right? We don't have to be snake. Okay, that's the first step, or first beginner step, that we generally follow. That's why I'm saying that if you have the self-driving car, let's keep it straight in the same path. Okay, all right. Yeah, so lane detection looks something like this. So as you can see, this is one lane. And by the way, one road can have multiple lanes. I hope you understand this, right? For example, highways, they have sometimes 2 or 4 or 8 lanes as well. So that's why we prefer to be in our lane only. So this is how a lane detection look like, and we'll be talking about how we can do this. It's a part of segmentation only. So I hope you can see that it's called two line two line lane detection. Two line lane detection is because that there's one line over here, there's one another line over here, and this is the path that where we can travel, or where we can move our car. Okay, different examples you can see. For example, this is another application, another video, right? This is also telling the same thing, that hey, this green one is the lane that you cannot go beyond this or beyond left. Okay, typically we will not I think this is fine, right? So you understand this. Now how we can do this? If you search for that, how we can do lane detection, there are the research paper, there are complete research paper there. They have a lot of researchers have done or written the research paper. They have done a lot of research on how we do the lane detection. But uh, before moving to the lane detection, how we do, we'll talk about very briefly. Let me tell you what are the different computer vision tasks. What is computer vision? Computer vision basically means if your machine or a computer has a vision. Vision means ability to see. If I can see that, hey, there's a pen, there's a camera, there's a laptop, there's a monitor, there's a mic, all these things, it means I have a vision. If I can count that number of people, 1 2 3 4 5 6, these are 5 6 people, it means I have a vision. Similarly, if computer can understand or a machine can understand what is there in front of this machine, what is there in front of the camera, it means computer also has a vision. So human vision, taken it to the machine, it become computer vision. Let's talk about the different tasks that are there in the computer vision. So so forget about this. We are not talking about the first one, so forget about this. Okay, we're starting with the classification. Classification basically means that you need to categorize this. Now if you look at this image, you can easily tell, hey, there is a cat, there's a cat. Okay, there's a cat. So if your model can tell just by looking at this image that there is a cat, it means you are doing classification. Okay, classifying the objects or classifying the images. Then there's another thing called classification is fine, but you're saying cat is there, but where is the cat? Can you also give me the location? So that's what called localization as well. So as you can see, you can also point or you can create a box. It's called localization. Okay, but this classification and localization with the single object. If you have dog as well, if you have a dog or horse or a human, multiple object, then these two techniques will not work. Okay, if you have multiple objects, then we will have to move to something called object detection or segmentation. Now object detection says that, okay, I will do classification plus localization but in multiple objects. For example, you can see there's a dog, there's a cat, there's another cat, there is a duck, and the detection can actually detect that there are multiple objects. Objects can be animals, humans, maybe road sign or traffic signals and all these things, right? But what is interesting about the segmentation is it not just gives the box, but it also tells that, hey, this pixel belongs to a dog. Look at this, right? This pixel belongs to the dog. This pixel belongs to a cat. This pixel belongs to a different cat. This pixel belongs to a duck. So that's why segmentation is slightly more complicated than the object detection. So if there are four tasks: classification, localization, detection, segmentation. If you have to order them in increasing order, right, or maybe the complexity of the algorithm, classification is the easiest one. Then localization, object detection, and the image segmentation. So if you come to this lane detection, you will be able to realize, hey, this look like a image segmentation part only, right? Because I'm trying to segment, I'm trying to find that out of other areas where my lane is. If I'm currently working on this, I'm running on this lane, then this is my lane. So I have to work, I have to run on this lane only, right? So this is how you can relate the lane detection with the segmentation. Although there's term called detection, but it can be thought of like a segmentation problem. And if you search for the lane detection, there will be a lot of research papers that you can come across. This is the first link that appears is papers with code. Now paper with code is a wonderful website if someone who is from the research community or have done researches, right, or have maybe read research papers, then papers with code is a wonderful website. So if you just search for lane detection, it will show that there are different type of models. There are different type of models and algorithms and the researches, right? So it is actually the detecting lanes on roads from a camera, same thing that we have just discussed. So obviously people, lot of researchers have tried multiple approaches. Some works in different cases, some works with different data set or maybe different scenarios. right? So this is what we have to do. And if you want to go into more details, maybe you can work, or you can click on this and understand the paper. If you click over here, you will get the paper, what it actually does, right? How it actually find the lane, all these things you can get. uh, uh, and also there is the code. If you want to get the code on GitHub, there is a code. If you run this code exact same, you will replicate the output as well. Okay, so they have open source their paper, research paper as well, and the code. So if you want to execute and do things, you can do it easily. It won't take a lot of time, I think. Okay, so as you can see, there are multiple models and the different data sets. By the way, if you want any data set as well, you can get data set over here. Just go and get the data set. So yeah, there are available data set as well. You can take these data sets. Okay, and the terms like this, the terms like the convolution, right? So convolution suggests that, hey, they are working with a model called CNN, convolutional neural network, which is a part of deep learning. Okay, there is a model called ResNet. I'll come to this. There's a model called ResNet that also works on CNN concepts only, right? So all these things are the part of deep learning itself, deep learning area, let's say. Okay, so this is one part. This is the one of the most important or the basic part that we need to solve. And by the way, if someone who is interested for the segmentation, who is interested how do we do segmentation, then there's a research paper, or again there is a model. It's called unit. Maybe I can very briefly talk about how it does, and how the segmentation actually works. So now I think you understood that there is a big model, there's a big machine learning or a deep learning model that takes input and it outputs something. But in this model, there are multiple tasks that this model is doing, right? There's not just one task, there are multiple tasks. One is lane detection, and then there would be object detection, where you have to find pedestrians, where you have to find the traffic signals, where you have to find different things, right? Object detection would be one thing. Then classification would be there. So multiple things have been done in parallelly. So there is not just one model in self-driving car. There are multiple models that you have to work with. So if there are multiple models, let's say there are three different models. So you have to work with these three different models. Okay. So let's talk about the first model, which is segmentation. How segmentation actually works. Understand that for segmentation, I have an image. Okay. Let's say why I'm calling it as an image, because I will get a video frame at any time, timestamp t. Let's say at your timestamp t, I'll get a video frame. And what is video? Video is a sequence of images. So I'll get one frame, and in 1 second there are, let's say, 24 frames. So that's how it becomes 24 fps, right? If you are familiar with video, so videos like 24 fps, 30 fps, 60 fps, it means 30 frames per second. So I'm talking about just one frame. So let's say in this frame you have a road, something like this. You have road something like this. Here's your car, and there are some trees. You get this as input image. Now the first model, what it's called segmentation model, or let's say line detection, lane detection, segmentation model. What this model will do, it will take this image as input, and it will output another image. It will output another image, and the image will be exactly same as this image. Let me tell you how. The output will be exactly same as this image. The only difference would be, in the output image, there will be marked boundaries. There will be boundaries like this. There will be boundaries like this. And maybe here the shaded region that, okay, you can drive in this area. Okay. As you can see, input is also image, output is also image, but the output image is shaded, or having the segmentation mask, right? This is what we have to do. Okay, this is what we have to do. Let's also dig, or let's also understand what is happening in the segmentation model. Okay, very quickly, or very briefly, let's understand what is happening, how it is able to do this. Recognize and what's understand what's happening, what's in their what's in the image. What happens in this is, uh, we try to extract the features. Now I'll take a simple example. I'll take a simpler example. Let's say that we have, this is one part, right? I hope you understand this is the segmentation. But not just the segmentation, there are some other other task. One such task would be the object detection. You again familiar with the object detection? Let's talk about what is object detection. You have an image, you have an image, and in this image there is a sign, and they have mentioned that stop. There is this road sign. Okay, if you are driving a car and you see this sign, then it actually means that you need to stop. But how this machine learning or the deep learning or the model, or let's say the car, will able to identify this? So what they need to do is, they need to take this part and they need to read this. What is there? What is written in this? Stop. It means that stop. Okay. So what they do from here, from taking this input as image, this is the model number 2 inside the overall big self-driven car. Model number 1 was that actually does the lane detection. Okay, this was the model number 1. Model number 2 is when you have to do the object detection, something like of that sort, right? Maybe object detection, or a classification, identifying that, hey, this is a stop sign, or if it is a left sign, right sign, or slow down sign, or maybe speed sign, max limit, max speed is 50, max speed is 70, something of that, right? Now given this input image, what you would have to do, you would have to identify that, do you need to press brake, or what you exactly need to do? Something like give the output, give the output. Okay, now output could be slow down, output could be slow down, output could be press brake. Okay, or what is written in this? It's written stop. Now the machine, the algorithm will try to understand what does stop means. For us, we understand stop means to stop, stop means to put brake, but computer or the machine needs to understand what is stop means. They cannot differentiate between start and stop, or maybe slow. They cannot. Computer cannot understand English, right? You know this. They cannot understand the English characters. They can only understand basic maths, that hey, 2 plus 2 is equal to 4. That's it. So somehow I need to take this English character and I need to convert it into the numbers. Okay, so somehow I need to encode that stop is written over here. I need to encode this important feature to numbers, and that's what we call as feature encoding. And this CNN model, right? You know about CNN, right? We have been talking about deep learning and this convolutional neural networks and neural networks. So what they do is, they try to do the same thing. What CNN does, they try to get feature mapping or feature encoding. Now you would ask, hey, what is feature? Feature means a characteristic. So if I ask that, hey, there is the image, what is the characteristics of this image? Or let's take a random image. Let's take maybe cats. Let's take cat's image. Hmm. Now, for example, let's say this is one image. You might ask, okay, you'll ask, hey, what is feature in this? There are multiple features. One feature is, if you look at the ears of a cat, ears of a cat are always the slopy ears, right? This pointed ears. Whereas this ear of a dog, ears of dog look something like this. So there's a difference, right? There's a difference between cat ears and dog's ears. So this is one feature of a cat. Another feature of cat is the eyes of cat. They're different from human eyes. They're different from dog eyes, so on and so forth, right? Similarly, there are mustaches, right? and the tail of cat would be different. If you search for the tail, maybe right. So you understand that there are different features in an image. Similarly, if I have this image, which is a stop sign, there will be multiple features. So stop sign, road signal, right? So something like this, stop sign, road. Okay, look at this. So one feature could be, it would always be in a red color. Okay, it would always be in a red color, and then this pattern would always be there, that stop. So these are the features that CNN model try to extract. And once it has extracted these features, it try to identify that, hey, do I need to stop? Do I need to start? Do I need to slow down? What I need to do? Okay, so that's the job of CNN model. Okay, I hope this makes sense. I hope you're able to understand how things are working, right? So in again overview, there's a big model and the multiple tasks are there. I'm just talking about the computer vision side of the task. There are also things where you have to do with natural language processing. You need to understand, if I give the command to, or if I give a order command to the self-driving car, right? They need to understand what I'm saying. For example, turn on the radio, or turn on the AC, turn off the AC. So they need to follow these commands as well. But we are not talking about that, because it's not about driving. It's just that would be just about improving your experience. But let's talk about the driving part. So driving part comes under the computer vision, where the car need to understand the roads, the other elements like other cars. So I think you understand that if you have to drive, if the car needs to drive in an empty road, it would be slightly easier. That you can just simply do the lane detection, where you can find the lane, and then you can try to put your car in between these two lane, left lane and the right lane. Okay, and then again, it depends on the curvature, right? For example, if this road, let's say if this road turns something like this, what your lane would be, lane would also be turning like this, the curvature of the lane, right? So this curvature actually decide your steering angle. This curvature, if the road is turning towards left, then it will decide your steering angle. So I think that would also be easier, because if you have the idea that it is moving towards the left or towards the right, then you can identify that as well. Okay, makes sense. So this was about the model 1. Similarly, model 2 was detecting the object. This was empty road, that's why I have not taken other cars. But obviously in the real world, other cars would be there would be trucks, there would be pedestrian. So now let's talk about the second variant, where, by the way, any questions meanwhile, before we move to the second phase, where we can talk about the challenges, and how do we overcome with these techniques like object detection, where we can identify other cars as well. I'll be talking about very briefly about the forward and backward propagation in the CNN networks. But obviously we cannot go into the full depth how CNN models have been trained, or how they are trained. Any questions? So the next step would be to drive in traffic. Okay, for example, with the normal world, if you have other cars as well. So what your goal would be, to avoid the collision, right? You need to avoid the collision. This is one important thing. Obviously, you this is the one of the most important thing. For example, lane detection was the most important in self-driving car when you have the empty road, because there is no scope of collision. But here there is a scope of collision even if you are in your lane. So avoiding collision is the most important thing. Okay, and we'll understand how we can do this using object detection. Okay, so driving a car with or without other cars are two different, totally different problems. So one, you can use this idea that lane detection will still be used over here, but you need to add more things, more, you need to make it more complex. So far we have just talked about, hey, you need to take left turn, you need to take a right turn, you need to take, maybe you need to speed up, right? You need to accelerate, you need to brake. But in real world there can be millions, there can be lot of different scenarios when there's another car that comes in front of you, or maybe if there is a pedestrian, what would you do? There can be lot of different cases. So having just four or five maybe outcomes is not sufficient for the machine learning or a deep learning model. Although as a humans we can do the mapping, we can make the combination of left, right, accelerator and brake, and then we can avoid the collision. But the self-driven car, the machine learning, deep learning, they're not very smart, not as smart as humans are. Okay, although we call them the smart machines, autonomous vehicles, but they're not that smart. Okay, they need to have more understanding, and that's why just like left and right and accelerator brake is not sufficient for them. They need to do a lot of processing. uh, so let me give you two different ideas or two different statements. You're driving a car, not you driving, but let's say the car that is, let's say your model is this self-driving car. Okay, you have this self-driving car, and there is another car over here. Let me draw it in uh, red. Okay, so there's another car over here. Now what you would do, you will do the object detection. You'll do the object detection and this object detection will identify that there is a car in front of you. So statement one is, it can identify that there is a car in front of you and it can put a box. Hey, this is where the car is. But the second statement is, if the model can also tell the car is in a different lane, let's say the car is in different lane, not in your lane, and it is maybe 10 meters ahead of you. If you are in this first lane and the car in second lane, maybe if it can also tell that, hey, this car is 10 meters ahead, or maybe 15 meters ahead, or maybe it is just 5 meters ahead, you need to be very careful now. Okay, so if your model can also tell these type of nitty-gritty details that are important to take decisions, then I think it would be helpful, right? So we do not want just the object, where the object is located. What we want how far this car is from us. Okay, I hope you can make sense of this, you can understand why it is important. Because if it suggests that, hey, the car is just maybe 5 meters ahead, you need to press emergency brakes. If car is maybe 50 meters ahead, then the model say, hey, there is a car, but the car is very tiny. I can find the car, but it's very small right now. It is because the car is very far from you, and you can accelerate that. That's fine, no issues. Okay, so again, these type of things are important. Now, how would I get the distance between this car and this car? Now in this, there are some different technologies, some advanced technologies that are the radar technology, or lidar technologies that we typically use in self-driving car to understand the distancing. So if you just search for these terminologies, you must have heard about them. I'm not sure if you have heard or not. Okay, so what it does is, it actually stands for light detection and ranging, and it is a remote sensing method that we can use to put the laser light, and we using that light, we understand there's an instrument that throws the light, and when it reflects back, it actually tells that how far this object is from the current position. Again, using radio wave. If you talk about the radio wave, I think that would be radar. So radar actually uses radio waves. They uses radio waves. Correct. Correct. They uses radio waves. Correct. So these type of technologies are used to identify that how far the object is from your current location. Object has ID that used to track the object in the image. I didn't get the statement. Object has the. I hope you understand about very. even I'm not expert in these technologies or these instruments, but I know the basic idea that we typically use these instruments if you have to build a actual self-driving car. Okay. And not just the distance between these two cars, but but maybe how for example, if I have car over here, this is my car, and this is a second car. Let's say second car is very far. Not just the vertical distance, but how much is the horizontal distance, right? If by mistake, let's say your model says, hey, there is a car that is 5 meter ahead of you, there's a 5 meter ahead of you, and the car is actually over here. The model is saying, hey, it is 5 meter ahead. It's true, but it is not telling that it is also away from me, right? So you need to understand all the different type of distances. That is also important. Okay, so you need to understand this distance as well. Or maybe overall you can take the Euclidean distance if you want to take. This would be the Manhattan distance if you take both x-axis and the y-axis. If you want to take overall distance, that would be the Euclidean distance. But Euclidean distance might not be very appropriate, because you won't understand if it is on the left hand side or the right hand side, or if it is it exactly on in front of you. For example, if you have this car, this is my car, there's a car that is exactly front of you, there's a car that is on right, there's a car that is on left. All three will have the same distance, but I don't have danger with these two cars, right? They are working, they're running on their own lanes, so no concerns with this. So that's why Manhattan distance also is important, that you need to understand what is the difference in the x-axis also. Okay, so let's say this is lane number 2, this is lane number 1, this is lane number 3. So if they are working, if they are going on lane number 2 and lane number 3 and lane number 1, I don't have any concern with them. So they can run parallelly, no issues. But I should be aware that there's another car that is in the same lane. Okay, so these type of things, model number, let's say 4, model number 4 will output these type of things when you are working with a traffic, when you are working with a self-driving car that works in a traffic. In traffic basically means you have other cars as well. I'm not talking about the Delhi Bangalore traffic, but with other cars as well, with other cars. And maybe there is a zebra crossing, maybe there is a zebra crossing as well. There can be zebra crossing, right? Now zebra crossing has some pedestrians, zebra crossing has some pedestrians as well. So this is, let's say, one pedestrian, this is another pedestrian, this is they're crossing the road. If you are there with your car, if you are there with the car, again you need to understand there's one person, this second person, this third person, fourth person, and these folks are crossing the road. Once they all have crossed the road, and you can see that there's no one in this area, then you can move ahead and you can cross this way. So they need to go away from your vision, from the car vision, they need to go away. And how would you recognize that they are still there or they have left? It's by, again, object detection. So let me do one thing. Let me detection, yeah. Let me walk you through how we can do object detection with person, right? How we can detect this one person, second person, third person. And same idea will be there with the cars as well. If you have to detect first car, second car, third car, or how many cars are there in front of you. Okay, all right. So always remember that there there will be supervised learning. We will use the supervised learning. We will use the supervised learning. So those who are not aware of what is supervised learning, here supervised basically means to tell that, hey, you are doing wrong, you are doing right, you are maybe somewhere in between. You can improve by providing some feedback, right? So supervised is like training a model by giving them feedback, giving or telling them, hey, you are doing correct, you are doing wrong, sometimes you're making these mistakes. This is what supervised, right? Supervision. So in supervised learning, what we do is we have the inputs, we have the outputs. Okay, let's talk about the object detection, where we have to find or identify. Here we have the people. Okay, so input will be image, Input will be image where there will be maybe 4 or 5 people, where there will be 4 or 5 people, something like this. And output will also be an image. Output will also be an image, but this image, output will also be an image, but this image will have these boxes. So output says that, hey, I have identified these folks and here is the location. It will also provide the coordinate. So maybe coordinate x and y, coordinate of this, what is the length of this box, what is the width of the box, what is the length of the length, height, width, what is the coordinate of x and y. So all these things will be provided by the model, and this model will be the machine, a deep learning model for object detection model. Now let's understand how this is trained. Let's talk about, we will use CNN model for this. And one very common or very popular model for CNN that can do this object detection, it's called YOLO. You only look once. So what it does is it look at the image. Okay, we'll understand how it find these folks, these people, how it identify. Okay, we'll try that, we'll try to understand that. It only looks at the image and find that feature mapping. You remember what is the purpose of CNN? CNN purpose is to understand the features. Now if I give you this image where there are 4 or 5 people, different people, what is the feature? Feature about these people are, they have 2 hands, they have 2 legs, they have a face, right? So all these are features of a human, of a person. So if I can identify, hey, there is this feature, right? Oh, okay, there would be one person. There is another feature, same features, 2 hands, 2 legs, one face, all these things, there would be another person. So CNN try to extract the features. It try to extract the features, and we don't have to do it manually. We don't have to do it manually. No manual. Deep learning says, just give me the data, I will do on my own. Just supervise me that, hey, so what it will do, you will give the data. Okay, you will give that, hey, these are 10 images, and in these 10 images I will tell you that, okay, here you have person, here you have person, here you have person, here you have person, right? These boxes. Now the model, which is a CNN model or a YOLO model, which is a variant of CNN, also used for object detection, what it will do is it will randomly put boxes, and it will ask you, hey, am I doing correct? You'll say no. When I'm saying, you'll say no, it will be automated program that will do automatically all these things. Okay. Again, YOLO will do random boxes, put random boxes, maybe 4 or 5 random boxes, and it will say, hey, are these the correct folks? These are the person? uh, you'll say no, these are not the right. Maybe you need to understand that, uh, move your boxes towards the left or towards the right, and then you will get the right person. It takes the feedback. YOLO or CNN says that, okay, I understood, good. It will again do the same thing. It will try to predict the boxes. The model will say, no, still not that great. You have made some improvement. Your boxes are somewhere accurate, but not very accurate. Maybe do more changes, and these are the changes that you need to make. The YOLO will say, okay, understood your feedback. I'll try to incorporate these feedbacks and again do some predictions. So it again do that prediction. The YOLO model again does that prediction, and now it says that, hey, I have made a prediction. Can you tell that if these boxes that I have predicted is good enough? You'll say now they looks great, and let's say the model predicted these boxes, so which is exactly equal to where you have persons. So you understand what is happening. You have a model, you do something called forward propagation. Which is also called as prediction. When we say that model need to predict something, it's called forward propagation in the deep learning terms. Then uh, then your model will say, hey, no, you have made some mistakes, this is not right. Okay, you need to maybe improve something. How does it understand that you need to improve something? There will be something called loss value. If you have made a lot of mistakes, loss value will be very high. If you have made tiny mistakes, small mistakes maybe, then loss value will be slightly lower. If you have made no mistake, then loss value will be 0. Depending on the loss value, it returns something called feedback. it returns something called feedback that, hey, because you have a huge loss, you did not make good prediction. You did not make good prediction. That's why the loss is huge. I'm providing you the feedback what you need to improve. And in deep learning, this is called backprop, or also called as backpropagation. So in forward propagation, the model output something or predict something. In backpropagation, it learns something. That's where the learning part comes. In backward propagation, always, how do we calculate the loss value? Good question, good question, good question. How do we calculate the loss function? Loss function we calculate using the training data. Using the training data. Okay. So how do we calculate loss value? Using the training data. What is training data? Let's say I have 100 images. I have 100 images. In these 100 images, there are multiple people, right? In one image, maybe 5 people. In second image, maybe 2, 3 people. In third image, maybe a few more people. And if for every image, I will also have the coordinates for them. For example, the one image number one, I1, image number one, maybe let's write image number one will have 4 people, and I know their coordinates. I know their coordinates. This are the coordinates. For image number two, I know the coordinates of the people. Now you might ask, hey, how do we get this data? There are labelers, right? There are some people who actually do this labeling. So there are actual data labeling jobs out there. Data labeling jobs out there. This is not very exciting, or not exciting at all. I really don't like this data labeling. But yes, it's true that there are jobs out there that is the data labeling jobs. Okay, these folks actually label manually that, hey, this is one person, they will draw a box, they will another person draw a box. So for all the 100 images, there are these boxes. Now when you give this 100 image to the model, let's say this is your model. Okay, this is your model. You give 100 image to the model, it, or maybe let's say one image. The model predict that, hey, these are the boxes. Now you can check with these, are these the correct, the prediction that the model has made, and the actual boxes, are they close enough or not? If they are not close, then you will say loss value is high. If they are very close, then you can say, yes, this is good. Maybe let's say I have done this 100 times, 1,000 times, 10,000 times, 100,000 times. I have done this multiple times. Now this model is very confident that no matter what image you give, I can identify where the boxes should be, where the person is. Once I feel that the model has trained so much, the model has learned good enough mapping that given any image, it can identify the boxes very well. Now what I will do, I will use something called testing data. I will use something called testing data. On this data, let's say I have 10 images, I1 to I10. I have never shown this data to the machine learning model or deep learning model. I've never shown this data, these images. So the model is looking at these images for the very first time. Because I want my model to be robust, that's why these images will be given. And now I will ask, hey model, take this image and predict that where should be the objects, or where should be the folks, these persons should be, what should be the bounding boxes. Similarly, take the second image and predict where should be the bounding boxes. Take all 10 images and predict where should be the bounding boxes, and so on and so forth. And this is how I can do training versus testing. Because in real world, there will be a lot of scenarios where your car has never gone to a different path. Okay, let's say A and B, place A to place B is very new, is completely new for your car. Your car should still be able to manage, because it is like a road only, right? It is a road between A, B, and A to B. Maybe multiple cuts, multiple roads, but it is between path from A to B. So your model should be robust enough to look at the new data, to work with the new roads, to work with different folks, or overall the new data. And that's what testing data also means. Okay, does it make sense? And how do we get the training data? Typically or generally, we manually collect the data, or there are some people, data labelers, or they do data collection, all these things. And then machine learning or deep learning engineer, they train the model. That's it. So overall, all these things I wanted to talk about in general, that This is how self-driving car actually works. These are the few components. I'm not telling that these are all the components. There's one major component that is also there, although there are a lot of things that we can discuss. But let's say you are right now at Lajpat Nagar and you need to move to Pitampura. There are two places, place A, place B. Now you put the destination, right? You put the location from place A to place B. How would this car be able to find the route or the path? There would be a lot of roads, right? For example, this is something like this. Again, I hope you know about the graph algorithms, right? The shortest path, BFS, DFS, right? The extra algorithm, A star algorithm. So all these algorithms are also important. Understanding the path between place A to place B, because if you cannot find the path, you will be just randomly working or randomly running on streets or roads, right? But you need to go to the correct path or the right direction. That's why it is also important for a self-driving car that they understand the path or road very well. Okay, so that's why the location will also be an important input. Okay, the geolocation basically, right? Where exactly you are, and from where, from you need to start from A to place and you want to go to place B. So how much is the distance that is yet to be covered? For example, you can, otherwise you cannot say that, hey, uh, uh, so send or maybe take my kid to the school or drop my kid to their school and come back. You cannot command this to your self-driving car if they cannot identify where they need to go. Okay, although we talk about a lot about the self-driving cars, but it is not feasible to use these things. Human intervention would be required a lot. For example, you need to always monitor that if it is working in a right direction, if it is taking correct steps, and all these things, right? So there is still a lot of time uh, before you can see any real self-driving car on roads. We can use some components of self-driving cars. For example, we can use it for auto parking, and even not, obviously not in India or very congested places, but uh, in some cities in US, they have done a lot of experiments where car can automatically park, car can drive on its own without the human intervention, but the monitoring is required. You need to be seated there, you need to understand if car is working fine or not. It's not that you just leave the car, it will go automatically and then you're working and then sitting idle, right? Chilling. You cannot do this. So we do not have this flexibility. Although a lot of companies like Uber, Tesla, Mercedes, right, all these Google, they are investing a lot of amount on, or time, in fact, on doing researches, doing experiments. But still, safety concerns would be there, and that's why we are not launching self-driving cars for commercial use. But hopefully there would, you might see that self-driving car, although you wouldn't have to do you cannot leave the car for a full journey, but there will be some instances where you can just leave the car for 15-20 minutes. If you are on a highway, you can leave the car for 15-20 minutes and you're just monitoring if it's working fine. So these instances you can see often. Any questions if anyone has, or any other part or component that anyone would like to discuss? Feel free to put questions or comments. By the way, if anyone wants to implement this as well, there is a mini course on Udacity. There's a mini course on Udacity on self-driven cars. There's a self-driving car, a mini course on Udacity self-driving cars. I would recommend you to check that course if you want to build a self-driving car. So let me, and again, it is done on the simulator. It is not done on a real world. It's called Udacity self-driving car simulator. Yes, yes. So they have the simulator as well. If you want to work with the simulator, maybe you can check their GitHub. They have open source their simulator, so you can, yes, something like this, right? So steering angle is this, and there is this car. If you not need to move to the left, then steering angle will move to maybe minus 50 degree, minus 50 degree. Okay, and similarly, so there will be different tracks. You can record this, you can train this. Okay, and you can use this car to check that if it can run on its own or not. But again, it would everything would be under the simulation. uh, One of my friend actually tried this in Bangalore road, but it was not very successful. It was great attempt. So the car was able to work pretty well. It was able to drive, but not very reliable that we can just leave this car and it will work on its own. So that I think we cannot do. But yes, one attempt was made. So just to check that if it is working with the real car or not. So maybe you can also, if you want to look for self-driving car simulator, you can also look for this one. Okay. Uh, any questions if anyone wants to ask? So the interface looks something like this. There is a training mode, and then there is the evaluation mode. So in training mode, you can collect the data, right? And then in autonomous mode or evaluation mode, you can just command your car to run on its own, okay, or drive on its own. Okay. Any questions if anyone wants to ask? Feel free to put questions or any comments.
Guys, if you have any questions, please do put it up on the live chat.
What we will be doing in the hackathon will be building a self driving car. So that you can definitely do, but there are a lot of other ideas as well. I think someone from the team can explain.
Hi, so during the hackathon, we have released a list of tracks that can be found on our website. You can go through those tracks, and any one of those will you can build during the hackathon. Self-driving car is something you can look into, but I don't think it would be feasible for 24 hours duration. We definitely appreciate it if you guys would like to try for this as well.
ML in object detection, how it works. Hmm. So there are some traditional object detection. For example, you can detect faces. Okay, this thing called face detection, which is a type of object detection which is specific to faces. But in general, these days, object detection these days are done using the deep learning. And deep learning is a subset of machine learning. So machine learning is a general term. Deep learning is a very specific term that works with the neural networks. So if you search for the CNN, if you search for CNN based neural networks or CNN based object detection, so you will probably find YOLO. The most common one is YOLO. Okay, and even you can try executing the code. It is not that difficult. They have given the code, and you can run this maybe within couple of hours, like 1 hour, 2 hour. They have given the entire code. Okay, they have given the instruction that how you need to run this, and once you run this, there will be video frame that open up, and if you put the mobile phone, or if you bring some objects, it will detect that, hey, these are the objects. So it might take maybe 1 hour, 2 hours to play around with this. So I hope you will be able to do that. In future, we'll be able to work on self-driving car 3 or 2. Okay, self-driving, not cars, but maybe bikes. Hmm. Good question. And definitely that would be one research area that a lot of people would be talking about, or putting their resources. uh, it is it is slightly more difficult. It is even more difficult than self-driving cars, because at least in cars you don't have to do the balancing. Okay, you don't have to do the balancing. In bike or maybe a scooter, you would have to do the balancing as well. That would be another thing that they would have to work on. Otherwise, moreover, it would remain same, that you would have to maybe manage the distance, or you would have to find the object, detect object, all these things would be. But productionizing these things would is slightly difficult. Putting it in the real world, slightly difficult. You can do it experiment for experiment. You can do it for your final project, the BTech final project or your college final project. You can do write theses on this, but putting it on the real world is difficult. These things works under the ideal situation, ideal scenarios. Is it possible to build this self-driving model using only Python? How it configures things with other component? Okay, all these things that we have discussed is using Python only. So Python, when we say Python, it automatically involves some libraries. Now, libraries like TensorFlow, which is a deep learning or machine learning library written in Python or for Python. Then maybe libraries like PyTorch. So if you just say that, hey, I only know Python and I want to build a self-driving car, uh, I would say you have a base, you have a foundation, but what you need to learn is deep learning. Deep learning is a fundamental concept that you need to understand. How does a model learns? If you don't understand how does a model learns, then probably it's slightly difficult. But if you understand how does a model learn, then implementing them in code is not that difficult. You can find a lot of implementation. And in fact, I would suggest, if you go and search for self-driving car projects, you can get code, you can get complete entire code. But what you will not understand is how these things are working under the hood. So for that part, you need to understand the deep learning. Okay. And how these things work with other component, then obviously there will be the data transfer between the sensors and your machine learning model, or let's say a computer or machine, right? Okay, so for example, you take a camera. If I use my webcam, I can get the entire video feed and I can save it in a video file. Similarly, if you have a different instrument that can sense something, that can find the color of an object, that can find the length, width, height, width, all these things of an object, then I can put that content in my laptop as well. So there is always configuration that you are talking about. Yes, there are definitely. If you pick any instrument, any input device, then it will have data to track or log. Any other questions if anyone has? Otherwise, we can wind up this session. It's already we have overshot by 15 minutes. So it, all right. Anything else if anyone wants to ask?
Guys, if you have any other questions, please do put it up on the chat. We'll wait for another minute and then we'll close. So I don't think we have any more questions.
All right.
So thank you so much for joining us today, sir. I think it was a really informative session, and I'm sure everyone else had gained a lot of information. And also, guys, thank you all for joining us today. And please do register for the hackathon. The link is provided in the description. And yeah, and also follow us on our social media.